I need to set that to auto start. There we go. Actually, can I just set it to... No, because I already started the stream. Alright. So, let me show you what I got working. If we go into CLI here, and then run cargo test. I think that's all I need to do. I might want to test... Why is it not doing anything? Anyways, I might want to test the... whatchamacallit? Specific binary, or specific testing, whatever. There we go. So some of the tests will fail, which are the sandbox tests, because these trigger code that have to be run in release, because they're actually testing like code going wrong, and usually Rust Panics will catch that. But yeah, anyways, this is different code. The code we do care about, somewhere in here, is... Actually, I don't see them. Do verbose. Does it do all of them? Where are my tests? Anyways. This is it. There we go. Okay. Basically, since the last stream, I've gotten the Windows function calling convention fully implemented into Brane script. What does that mean? This means that when you call a Brane script function from your host computer or whatever, this is just like, I had a chatbot spit out like a ludicrous amount of tests for as many like edge cases of function calling conventions as I can. There's like arguments of all different sizes and all different configurations, and we will need to add a couple more cases to this still for what we're doing today. But basically, if you see this function call signature here, this is the signature for a function pointer in Rust. So you just do extern C, so C calling convention, function that takes in a pointer to a bindings context, and then we're passing in just regular Rust structs with the Reaper C annotation, which means lay out this struct in the way that C would have a struct laid out. And then the other really fun thing is we even have Rust enums. So Reaper U8 for Rust enum means treat this enum as if it's a union, or rather, no. Treat each variant of this enum as if it is a member of a union, where first there's just the discriminant of the union, which in this case will be a U8, and then all the values of the data. So it's kind of like, yeah, that's how that works. Anyways, so that is now how Brane enums work as well, is they just follow this exact same convention. Now, I initially misread the docs the Rust docs, and I thought that this annotation here would make it so it was either Reaper U8 or Reaper C would. I thought about making it do Reaper C, but like I very much want to like let's just enforce the small size possible always. So we have it be explicit. So we're not using Reaper C, we're actually like having it be a little bit explicit, and transparent is part of that. So what this means is, since there's only one variant, the enum here basically doesn't exist. There's no discriminant. This is literally just a struct 16 byte. And BraneScript now automatically does that as well, to where when you have an enum with only one variant, it is basically the same as just the data of that variant, because why should we store a value telling us which variant it is when there is only one variant? So yeah, this makes it really easy to move data to and from all of our Rust host code into the BraneScript runtime, because we can literally just get module, get finalized function, standard mem transmute. We can just transmute the function pointer into the definition of, like, just straight up the definition of the actual function, and then when we run it, it just works. And all these tests are doing is it's passing, most of these are just passing the structure into the function and then out of the function. And that is a sufficient test in this case, because the way that BraneScript works is we don't have an explicit concept of a stack in the intermediate representation. So it is fully reading every single structure into registers and then rewriting it into whatever format needs, whatever format it needs to be put into that. How's the work on the engine coming along? This is the work on the engine, and this is a huge step towards actually using the scripting language in the engine, or in an engine. There's the possibility that I take the route of focusing more on making an internal engine for the studio I'm currently working at. It will evolve more into Brane. That's kind of like the main update there, but for now, we're just working on this. Yeah. So, as convenient as this is when we're actually using the functions, as convenient as this is, the inconvenient part about it is that the calling convention for functions is both platform, or both CPU architecture and, work with me here, both CPU architecture and operating system dependent. Basically, what kernel are you running and on what architecture? So we have implemented this on Windows x86 specifically. We have not implemented this on any other architecture, and the next architecture that it's important to implement it on is Linux, because we want to have a Linux build target. I might want to switch over my dev environment to Linux at some point. And then after that, we'll take the jump to Arch 64, which is what the Quests use. And also, I have the box. I have a Samsung headset behind me right here too, still in the box. I believe that also... Yeah. It's also running a Qualcomm headset, so that is also Arch 64. And that's what we'll need to run this on both of those two headsets. Thankfully, we can just use ADB to run REST scripts over a USB connection. So that's what we'll do when we get around to that. But x86 SystemV calling convention, which is what Linux uses, is unfortunately the hardest calling convention to implement because it has a lot of interesting rules. It is, in my opinion, an efficient way to pass, like the most efficient calling convention, because there's the least casting of data, if that makes sense. You keep stuff in the same registers that you're going to use them when... Yeah. So let's change over to WSL here. There we go. And now let's just run the exact same tests, and they should fail. Oh, wait a second. I just do rust up update. Yeah. So my Rust version is out of date on in my WSL instance. Okay. x86 unknown Linux GNU. Hopefully that works now. And eventually this will compile. We have to compile the compiler. It's almost done, it's just linking the executable now. There we go. So we should get a panic that just says, yeah. See ABI tests enum single 4B JIT panicked there. Not yet implemented. Actually, I know what I'm gonna do here. I'm gonna test something. Can I... grab the binary here. Throw it in my notepad of commands. There we go. Then I set up NVIM on both my WSL instance and Windows instance, so It doesn't matter if I'm on Windows or Linux, I can still use the same. Yeah. All right. So the thing I want to test is, can I test running code LLDB? Okay. So my debuggers do not work on Linux. That's what I was wondering. No, I'm switching. Getting too much work done to switch to Linux quite yet. Unrelated, but will you try to implement things to prevent asset avatar ripping? Maybe, probably a little bit. I'll at least make it so that there's like, there will be validation for you to be able to download an asset. Basically, you'll have to be in a situation that actually warrants you downloading an asset, but with the engine being open source, any code that I do to make it, any code I do to like encrypt or obfuscate or literally anything, it's an open source engine that will be like documented how all of the formats work. So I won't even have the ripping, if anything, would be worse because like you could fork the client and make a ripper client and it's like documented. It's not a solvable problem unless you're server rendering stuff. That is the only way to solve the problem, is for the assets to never exist on someone's PC. So, unless you want me pulling a meta and rendering Brane in the cloud, which I don't want to do, ripping will be a problem. Also, that would make it an entirely closed source or closed ecosystem, or completely unsustainable ecosystem. I guess you could still do a federated world system. You would just have each person be in charge of getting their own compute capable of rendering a video stream to every single one of their users. Technically, that would work. And you could make a client that's like, here, let's overlay these different streams from different servers. This is true. Legal system and all that. The legal system does not stop stuff like torrenting. But they will just figure out how to 3D scan it? No, because you also have scripts and shaders and all of these different things. So, like, yes, they'd be able to copy the structure of something, but they would not be able to copy the behavior of it. Whereas if it's actually on their PC, they can... The way to put it is they would get the result, not the source, and what you need to actually rip something is the source. And yeah. They wouldn't be able to get local behavior as well. Yeah. I guess in the case of like ripping, if there's server-side behavior, well, depends on how assets are distributed. If server code is shipped to clients as well, or if those are two different binaries. I don't know. It depends on the design. Alright. Getting to actual work, though. let me show you the code that implements the actual function calling convention. That would be in runtime, Brane backend LVM. And here it is. So here's where we construct the function signature, and we match on the triple of our current, the default calling convention. So we get the calling convention, and then once we have checked the calling convention default for our current architecture, we switch on the actual architecture. So for instance, SystemV is implemented differently on x86-64 and Arch-64. So these are the two that we're currently targeting that are SystemV dependent. And then, of course, Apple has its own calling convention, so if we ever want to ship to an AVP, we'll have to implement this. Or if we want to run this on, on an Apple device, then we'll have to implement this as well. Which I will have to do at some point, most likely, but for now, we're covering the gaming laptops. Likely be the way Resomat approaches this in the future. There will be a way to create licenses by proving you're the author. Be able to do some asset fingerprinting when users upload licenses to the cloud. See if when they upload it as a licensed asset and circumvent them from using it as it is. Okay. Now, Resomat is more so able to do that because they are an actual platform that is centralized. My problem is I'm trying to make this decentralized thing, and I know oh, decentralization, and now the crypto bros are going to show up. No. But it's really hard to actually enforce. If I can't ban somebody, I can't get them to actually do anything. And to be clear, I moderate the worlds that I host and the assets I host. But it will have self-hosting ability, which, straight up, by definition, I shouldn't be able to moderate. Alright. So the two things that we need to handle are the signature and if it uses a return pointer. So for now, we're going to start out by copying the Windows code just to give us some structure. Then we're changing the call convention to SystemV. And I just manually putting in this in there because I can. Don't have to call. We technically are using the system default, but I'm you know what? I can put in the calling convention manually here, and it feels good because we are manually implementing this. This obviously only works for assets that are stored on the cloud and requires the cloud to be somewhat opaque, so I don't think that would apply to your engine. Yeah. Okay, so now we get to have dang it, the thing I was using I guess I never checked to make sure that after I rebuilt the... It's actually really funny. I want to debug that right now, but I'd have to log into, like, all the Cloudflare... Not Cloudflare. I'm just seeing Cloudflare because that's where the DNS is hosted through. It's not hosted on Cloudflare. Dang it! Okay, let's see if I can remember... No, I need that article backup. Dang it. Okay, give me a second while I fix my forums real fast. That's embarrassing. Like, alright, let's check my forum post where I talk about... Alright. It's just a standard... It is just a standard discourse site, so I do wonder why... Stopping old container. This looks like it's working. I should have just, like, gone directly to the IP. Oh no. I need the actual... the web request to be from a domain for it to actually accept the incoming connection. So that's super weird. So bear with me. While VPN maybe? Nope. I don't use a VPN on my main computer. And also it works over VPNs as well, because I've, like, my phone I do use a VPN. And I have access to my forums from a VPN as well. It's fine. It's a publicly hosted thing. In any case, I'm going in and I'm rebuilding the discourse. Is it done? No, it's not done. Takes a... The, this course is written in Ruby, so it takes absolutely forever for it to build. Especially because Discourse is, like, you, like, build... It has a utility that builds an entire Docker container for you and then runs that. Um, okay, I am getting an error. See. Okay, so you do just do rebuild app and then it's all good. So I'm gonna go into Cloudflare. And have it stop whatever the thing is where, like, it's piping data through itself. Or proxying. I'm gonna have Cloudflare stop proxying. And see if I can just go to the thing. See, where is... Ah, there it is, DNS records. So let's make a name not proxied, DNS only. I don't know how long the time to live will take to update there, but let me check from my phone. This is really annoying because, like, the docs that I'm using and I want to make sure I'm using the same docs. Okay, yeah, this is still saying it's down. Maybe that rebuild just got messed up somehow. Let's try it again. not how I wanted the stream to go. Okay. Maybe I can find this document a different way. Or the same document I've been referencing. AMD64. System 5? Is this it? System 5 application. That's AMD 664. AMD 664. Oh, it's 86. Oh no, it is AMD 64. Is the correct document. This is the x86 ABI for C99? Okay. So I found it. You just double check to make sure. Okay, I'm just going to close out all of my like management windows because I don't want like to really stream. I really don't want to stream like information about like actual servers I'm hosting. But I found the document and I'm just gonna leave the LSH console filled to bootstrap. Okay. Yeah, so there's something up with my discourse configuration right now. Alright, I need to come back to that later because we're streaming right now, but I can't just, unfortunately can't just like have a rebuild and then it will be good. But yeah, here's the AMD 64 document that we need to reference. x86 64, AMD 64. And we need to reference the function calling sequence. And this is what we need to reference to implement the function signature, the calling of functions, and the reconstruction of args once we are in a function that is being called, and also returning arguments. So those are the 4 things I think that we need to implement here. Yeah. So first off, we need to construct the function signature, which will be fun. I wish that it doesn't annoy me that the function calling sequence on AMD 64 is it doesn't matter to me that this is like complicated to figure out, but I do wish the Arch 64 dang it, my browser history really isn't helping me out here. This one all the way up at the top. Then that's AMD 64, not the one that we want. There's the Arch one. Because for stuff like this, you can't use chatbots. You do have to use the actual source. But the really nice thing is that it's kind of hard to find these documents. You can just ask it to source you documents, and it'll give you them. Which I did somewhere, but I can't find it, which is why I wrote them down in that blog post. Okay. I really like the one it sourced me before. Procedure. False. This it? This is it. This is the document. Okay. Parameter passing, I think, is it? Subroutine calls. There we go. So here they lay out they basically give you an entire algorithm. They even give you variable names to use. Like the next general purpose register number, the next SIMD and floating point register number, the next stacked argument address is set to the current stacked pointer value. Yeah, so we're basically gonna have to just straight up re-implement this algorithm and then pass certain stuff to CraneLift. And we have to re-implement the algorithm fully because in there is a little bit about like you can't pass a structure half in registers and half on the stack, so you have to figure out like if you're out of registers, and there's not a way for me to do that using CraneLift's abstractions. So we have to write the entire calling convention and then slightly account for the abstractions that CraneLift gives us, which is the like we don't have to care about stack versus registers. For most of everything, we just have to care of, like, can we pass this structure fully in registers or not? And to do that, we have to track everything that we pass into a function, which is a pain. But the thing is, if the argument is a composite type, yada yada yada, the argument is passed as though it has been loaded in registers from double word aligned addresses. So basically, you cast. Oh joy! I just realized. The argument is a composite type, and the size in double words of the argument. Double words. Keyword is 64-bit. Double words are 32-bit. So if the argument is passed as though it has been loaded into the registers from double word aligned addresses with an appropriate sequence of LDR instructions loading consecutive registers from memory. The contents of unused parts of registers are unspecified by the standard. The next general register number is incremented by the numbers of registers used. So, ARM 64-bit, yeah. So that has me concerned because parameter result registers 0 are 7. There are 31 64-bit general purpose, 64-bit. So there's that many general purpose registers, but it looks like, if I'm reading this correctly, composite type, not more than 8 minus. Then the argument is copied into consecutive general purpose registers starting at the argument is passed as though it had been loaded into the registers from a double word aligned address. Oh, thank goodness. Here, loaded into registers from a double word. I was like freaking out there because I thought we were passing it as 32-bit chunks instead of 64-bit chunks. And I was like, that makes no sense whatsoever. I already had the code to cast structures and registers into a bunch of 8-bit values. Or not 8-bit, 64-bit values, 8-byte values. So yeah, this is fine. Basically, what I was trying to get to a while back, before even trying to find this document, is what I'm annoyed at isn't that this function calling convention, I'm not annoyed at this function calling convention being complex. Because they give us an entire algorithm for like classifying your data and then deciding how to pass it. And you can't, in this function calling convention, you can pass structures on the stack and on the heap at once. Like, if one 8-byte chunk of your structure can be passed in registers, and the other part can only be passed in memory, well, actually, no. If the structure should only be passed in memory, it only gets passed on memory. But if your structure is... if you've run out of registers to pass the data for the struct into, you still construct these struct values as you would before, but then you just pass them on the stack in the same way that you would for like, let's say you have an SSE argument to the function in general. There are two different ways you can pass this. So you can pass this in a register, or you can pass it on the stack if you've run out of SSE registers to pass it in. If you have a structure that could be passed partially in registers, but you run out of registers, but if you have a structure that could be passed fully in registers, but then you run out of registers, you can still pass it partially in registers. In this version, you can only pass it in registers if you can fully pass it in registers. If it is a struct that can be passed in registers, it still isn't passed in registers at all if you can't fully fit it into registers. And also, this format here, it lets you pass parts of structs in vector registers if there's if you have two 32-bit floats. I'm pretty sure you pass them in an XMM register together, which, yeah. So basically, in this version, I literally have to maybe pack floating point values, whereas in this version, I can use the exact same code I wrote to cast structures to one 8-byte value or 8-byte register, and I can just cast a struct to multiple 8-byte values because the code can do that. In this one, we have to invent new utility functions for casting structures. Anyways, let's get into actually implementing the algorithm, though. Sorry for the huge, like, this calling convention versus this calling convention. Structures. I am fully sane and retaining my sanity. These are all the different register types. For this one, I don't think we need to... We don't need to fully re-implement the calling convention. We don't have to do what we have to do here, where we have to write the algorithm as described in the spec doc. But in this one, I do kind of want to write the algorithm because it's a fun algorithm, but we only have to write the algorithm. Actually, no, we don't. We do have to fully write the algorithm, but only the struct portion of it, whereas this one we have to write the entire argument. Yeah. Okay, so... yeah, let's just read through this to start off, to figure out where we need to start here. If the argument values have been computed, they are placed in either in registers or pushed on the stack. And I want to see if I can figure out, like, if they do want me to pack multiple floats into a single SSE register. Which in this case would be an XMM register, not a YMM. Though, very fun, they explicitly say here that for the purposes of parameter passing function returns, the XMM and YMM refer to the same register. So when they say XMM, which is a 128-bit register, they could be meaning YMM, which is a 256-bit wide register, which really confused me because they literally have stuff in the spec that makes it look like they want you passing 256 bits of information in an XMM register, which is impossible. Sanity is overrated. I will agree with this. Insanity is underrated. Okay, so this is how we classify. These are the different classes that we can use for this sort of thing. But let me see to where we get to how they do. The classification of aggregate structures and arrays and union types works as follows. If the size of an object is larger than 4 8 bytes or contains unaligned fields, its class is memory, meaning we pass it on the stack implicitly. If a C++ object, we can ignore this statement because they're like, oh, by the way, this one language, then again, this is a spec for C and C++, not just generally like the spec for passing all functions on a platform. So I guess I can give them slack for accounting for C++ stuff, but yeah, if a C++ object has either a non-trivial copy constructor or a non-trivial destructor, it is passed by invisible reference. Basically, if we can't copy this thing, don't copy the thing. The size of an aggregate exceeds a single 8-byte, each class is classified separately. Each 8-byte gets initialized to no class. Each field of an object is classified recursively so that all ways that two fields are considered, the resulting class is calculated according to the classes of the fields in the 8-byte. Basically what this is saying is you have, like, when you're classifying an 8-byte value, you have to classify all the fields that you're trying to put into that value. And you have the current value, which is initialized to no class at first. And then you consider another field, and then you merge it in. And then you consider another field, and you merge it in. And you consider another field, and you merge it in. At first, this was, like, confusing, and then, like, I was able to figure out that that's what it meant, is it's just like, yeah, consider them one by one, and merge them in. Yeah. If both classes are equal, that's the resulting class. That's kind of a given. If one of the classes is no class, the resulting class is the other class. So, I guess no class is kind of... No class is like the default value, so that's like how they have to... They're giving us our like default assumptions. If one of the classes is memory, the result is the memory class. And if one of the classes is integer, the result is integer. So basically, if you have a floating point value in there, you then... If one of the classes is memory, the result is the memory class. If one of the classes is integer, the result is integer. So what if we have a memory and an integer? We can't have both memory and integer. I think the way that they try to explain it is, I'm going to assume that this precedes this. So you have to check, like, if it is memory, the result is memory. And then you can go, if one of them is integer, the result is integer. And then if one of the classes is x87, x87 up, complex x87, memory class is used. Does that mean if we have an integer and x87, like an 80-bit float, if we have an 80-bit float, does that mean we need to int cast this? If one of the classes is x87, complex x87 memory class is used. Otherwise, class SSE is used. We don't have to worry about x87 because we don't support x87 values, thankfully. Because, yeah, I don't want to deal with that. Otherwise, class SSE is used, so that's just like floats. If everything else, if we have anything but a float, do these things, otherwise it's a float. If one of the classes is memory, the whole argument is passed in memory. If x87 up is not preceded by x87, the whole argument is passed in memory. If the size of the aggregate exceeds 2 8 bytes and the first 8 byte isn't SSE or any other 8 byte isn't SSE up, the whole argument is passed in memory. So this is basically saying if you can't turn it into a vector, yeah. Its class has no virtual functions and no virtual base class, and all the direct base classes of its classes have trivial deconstructors. Okay, yeah, this is just what's... yeah. An object with either a trivial, non-trivial copy constructor or non-trivial destructor cannot be passed by returning values. Similar issues apply when returning objects from a function. So I do need to read this more carefully, the whole like how to pass stuff, because I need to figure out if you actually int cast floats or if you int cast x87, or if you can do two floats, like if you have two 32-bit fields in an 8-byte value, do you pass those both in the same SSE register? I just realized I could just compiler explore this. I could just compiler explore this and it would answer my questions. That's an idea I had yesterday when I was trying to debug stuff, and then I realized it was working. I had just forgotten to put my context struct pointer into like the function that I was casting it to. So the pointer I was expecting wasn't getting passed to the right register. It was actually the calling code that was broken, the Rust calling code that was broken, not my JIT compiler. And I was able to... I like made my function compile and compiler explore and saw the exact same assembly code behavior as my JIT compiler output, and I'm like, why is the function call still not working? It's because I was calling my own code wrong. Anyways, but I could actually use Compiler Explorer here to figure out how are we dealing with SSE registers here. So, once arguments are classified, the registers get assigned in left to right order, passing as follows. If the class is memory, pass the argument on the stack. If the class is integer, the next available register of the sequence RDI, RSI, RSX, RCX, R8, and R9 is used. I think for Windows, it's like RCX is the first arg, and then I can't remember the second one, but then it's R8 and R9. If the class is SSE, the next available vector register is used. So that's which register to use. what I'm confused about is aggregate types. So when a value of type bool is returned, and that just describes the, the first byte is the truth value. If there are no registers available for an 8-byte of any argument, the whole argument is passed on the stack. If registers have already been assigned for some 8 bytes of such an argument, the assignments get reverted. Wait a second, if there are no registers available for it. Okay. So I have already read this and reacted to it on stream. I am now remembering this. Both this one and this one. Okay, yeah. If we have a structure and we can't fully pass it in registers, then we do pass it on memory. I was wrong what I said earlier in the stream. I had forgotten what I said last stream. So we do need to re-implement the entire register allocation code algorithm. We do have to implement it for this. We do need to implement it for this architecture as well, so we can check if we can pass a structure in registers or not. Okay, if the registers have already been assigned for some 8 bytes of such an argument, the assignments get reverted, and then it's passed on the stack. Once registers are assigned, the argument is passed in memory. The arguments passed in memory are pushed on the stack in reversed left-to-right order. We don't need to worry about that specific part because crane left will handle it for us. For calls that may call functions that use variable arguments or standard args, AL is used as a hinder argument to specify number of vector registers used. Okay. Note that R11 is neither required to be preserved nor is used to pass arguments. Making this register available as a scratch register means the code in the PLT need not spill any registers. When computing the address which control needs to be transferred, REX is used to indicate the number of vector arguments passed to a function requiring a variable number of arguments. R10 is used for patching the function's static chain pointer. Other bits are less unspecified, hence the consumer side of those values can rely on it being 0 or 1 and truncated to 8-bit. I think that's talking about bool. Yeah, that's the annotation for bool. There we go. Right to left order on the stack makes handling of the functions that take variable numbers. Note that the rest of RX is undefined, only the contents of AL is defined. And then for returning values, it's basically the same algorithm, except that... Yeah, no, it's the exact same algorithm, except SystemV can actually return using 2 registers instead of just 1, which I think is pretty cool. So we classify the return types. The type has memory. Yeah, it's literally just classify the return type with the classification algorithm. And then that also takes into account if a Brane, work with me here. Yeah, this takes into account even if like a structure is too large, and a structure can only be passed in up to 2 registers, and System5 does allow for, or SystemV, I'm not sure if it's System5 or SystemV. SystemV allows for 2 integer or 2 float registers to be used to return values, which I think is pretty cool. That means returning on Linux is potentially faster in small structure cases. The type T of the function is result of require that arg be passed as a value in registers or set registers or granted rules. Interesting. Okay, I wasn't able to understand this block of code before, or this block of specification before, but I think I get what it's saying now. Basically, when you're returning any arguments, when you're returning something, you basically run this algorithm here that they describe to register function arguments, and if that would be passed fully in registers, then just pass the return value in those registers. That's pretty cool. And if it wouldn't be passed in registers, do a function pointer. Otherwise, the caller shall reserve a block of memory sufficient size and alignment to hold the result. The address of the memory block shall be passed as an additional argument to the function in X8. The callee may modify the result memory block at any point during execution of the subroutine. There's no requirement for the callee to preserve the value stored in X8. Okay. So this is the reason why Crane Lift has a function, a return pointer argument type, and that is because the whole Crane Lift has a struct argument type that's specifically used for System5's implicit memory, where it isn't actually like in a register. It's just known when you pass memory arguments, you don't pass pointers to those arguments in the regular argument passing system. The memory is just implicitly on your stack. And the function knows where to look for it because of the specification. Whereas in this one, you do pass pointers to arguments. But in this one, the return pointer needs to be in a specific argument, it looks like. in X8. Going to be R8, not X8. ARM 64 registers. Okay. So there are X registers. R0 through R7. I haven't actually done much research into ARM assembly code. So these are general purpose, do not specify bit width. Whereas X registers are... X and R can both refer to general purpose registers, but X has the specific meaning, whereas R is a more general architectural name. The primary difference is that X is used to specify a 64-bit. Okay, so they're the same register. So registers R0 through R7 are used for parameter passing. And then register 8 is used to specify a return pointer, but they say X8 in the document because specifically they want a 64-bit value. Got it. I don't know why I'm spending so much time on this. I'm not going to implement it. It's just really fun to read these. What is this doc? This particular document is the ARM 64-bit ARM, the standard for the CABI on 64-bit ARM for the SystemV SystemV function calling convention. So this is how to, in assembly language, pass arguments. I mean, not specifically just pass arguments, but that's the majority of the document. Procedure call standard. How to do procedure calls on Arch. Yeah. Because right now we're writing a JIT compiler, and I'm just comparing the differences between this spec, which I'm going to implement next, and this spec here, which is what we're working on now. And this is for SystemV function calls on x86-64, which is what we're implementing right now. Yeah. And I was just comparing how they do return values and all that fun stuff. Okay. So now I just need to decide how general I want this algorithm to be, and if I want to try to share the algorithm. With this spec. Doesn't really make sense to. But also this is going to be so much boilerplate. And I don't necessarily want to re-implement the entire algorithm every single time. Which I don't think we need to. But the first thing we could do is create a way to get the 8 bytes of the 8-byte specification the 8-byte class of our argument types. So we can just do 8-byte class or get 8-byte classes as a function here. That will take care of that. And then we can just iterate over those. But first, we're going to do Compiler Explorer, and I'm going to figure out if we have a structure. Oh, you can see here's my tests of like function calling conventions. Let's do... Oh, that's cool. So we can do compilers, multiple compilers for multiple things. So let's do C. I just want C because we are implementing the C calling convention. And then we're going to do struct value, and then this need a semicolon? It does, okay. So we're going to break this into 8-byte chunks. So if I have an int A, int B, obviously that is going to be your compiler options. Hopefully this gives me the command target. It's the GCC. Is it just triple? Target. During toolchain configuration. Is GCC B. Not past the standard triple command to GCC. Might want to use LVM then? Or Clang. Oh, actually, it's on x86 GCC already. So how to get it to output to Linux? GCC has to be configured before compiling for a specific triple. Well, how do you configure it before compiling? I guess, how do I get... Ah, here we go, here we go. Target architecture... Well, x86. Oh. ABI environment variable? C99. I guess we'll just do Clang then. And then... Or... So it's not target, it's triple. Target is the rest thing. Oh, wait. That worked. Okay. Bear with me. I don't write C very often, so I forget about the little differences between... So I'm gonna create a function here, call test. This is gonna drive me insane. I'm just gonna do that so I can just refer to this struct as just value. There we go. That should work. Oh, right. A lot of debug information. here on the call test. So where do we call the function there? Nothing interesting yet. But let's just see if I can. Let's move low, -12 into, or -12 RPP. Oh, okay, so this is where we're setting values. We move 42 into, and this is a stack pointer. I believe this is our stack pointer. So this is an address on the stack. So why do we move? Oh. I meant to put B there. I was confused why why we're moving 42 and then 84 in the same value. So that's where we initialize our stuff, and then move quadword. So it moved both this int and that int into the same register. We pass this in RDI, and then we call the test function, which surprisingly actually does stuff. So we have our regular function prelude. We like increment the stack, I think is what that's doing. The RBP, RSP, RBP, all that sort of stuff. So I think this move quad, that's moving it off of the stack into a register value. And then we move that register value onto the stack, and then we move from the stack onto another register, presumably as a return value. And then we move that back onto the stack. But at a different point. Wait a second. This is doing what my code would do. It's not moving it as a single... Is it moving? No, it's move Q. Move quad word. 64-bit value. Yeah. Wait. Copy is a double word. I thought the Q stood for quad. It's been a little bit since I wrote custom double word from a source operand. Second. Six. ASM. I don't want the Intel syntax. What's the other one? Is it AMD syntax? Is it A and T syntax? Because I know like there's the Intel syntax, which is this one. There we go, Q word, quad word. That's not D word, that's quad word. This is saying move Q. Copies a double word from the source operand to the destination. Maybe that description is incorrect then. It's like, that's definitely a quad word, not a D word. But yes, so this is moving from there into here. Anyways, I'm gonna stop. So this is moving a quad word. ASM move Q. A quad word. Compiler Explorer was wrong. It is not moving a D word. It's moving a Q word. So we are moving a 16-bit value here. From here into there. Prologue end. So then we move from the stack. So this is another quad word. Location is statement. So this stuff happens before the return statement, I think. Int should be... Wait, keyword. Am I stupid? Quad word is 60. Am I stupid? Oh, it is 64 bits. And then B is... yeah, 32 bits. So why are we using quad word? Move Q. Why are we moving quad words when it's double words? Unless, like... But there's no optimizations either. Here, I'm gonna change that. Anyways, I'm not sure why we're using quad words there, but... there's where we restore the stack frame. Then, I believe... where is return standard? Because this should be using the standard. REX, temporary register, first return register. Okay. Actually, is it RCX on Windows? I think it's RCX on Windows. So REX is our return register. So we move from the stack, move Q, REX. This makes sense. I have no clue what we're doing up here. These are kind of like these statements here don't matter. And then this one does. This makes sense. This is quad words. So this should move like that. Now, the two things I want to test, if there's an int and a float, I think that should be an implicit cast. But yeah, and then I want float C, float E. Let's see. Okay, so here we had a little bit of constant folding here. So we're moving this constant, which I'm guessing is the memory representation of... Wait a second. So here is like the memory representation of that float, and then it's moving it onto the stack. Memory representation of that float, moving onto the stack, memory representation of that float, and moving it onto the stack. Okay. Suspicions look like they were true. So when we have an integer and a float, it's casting them into RDI. Like, this is a bit cast. Storing on the stack and then loading from it, that's a bit cast, since it's just the memory representation. And then we are storing both of these floats in XMM0, which is what I was wondering. Implicit vector register or stack pointer? So here, so I believe loads effective address. Yeah. Of the second operand. So this is getting the pointers to stack values. Wait, loads effective address of the second operand. The source operand stores it in the first operand. The source operand is a memory address. Specified with one of the computes the effective address of the second operand and stores it in the first operand. So that's the same explanation for Intel syntax. And I think Intel syntax is the default. So it's like by default, this is what like it wants to show you. Basically, these are the new. There's the value v we see here, which is stored on the stack, and then there's a secret value v, or the value num being constructed before being passed into this function, because this, I believe, yeah, so we're moving this into RCX. And then we're using RCX to store it in keyword pointer RSP. So that's our stack. Loading it out of RAX, which is, yeah, and then the stack also is backwards, like in terms of functions. So this is stored at the highest address, and then here this would be stored at the lowest address because it's the last one. Weird ordering stuff. So that's why we're going from higher values into lower values. It's because yeah. So you do all of that, and then this is where we're actually setting the operands of the function. So I believe first return register, past first argument functions, RDI. So RDI here, this is our pointer. So this is doing a stack pointer. It's not automatically vectorizing all of our values here. But if we only had 4 floats, I do think it automatically vectorizes it. So if we go here to where we actually call it, okay, yeah. It doesn't auto-vectorize it. And that's because each 8-byte is separately classified. So both these get the class SSC, both these get the class SSC. If this got the class SSC up, it would be stored in the like in YMM0 instead of XMM0. So yeah, this is correct. I just keep thinking it auto-vectorizes structs because that's how I originally read it, and I remember that I have been corrected on this multiple times. Well, I've corrected myself on this multiple times. But yeah, so these are just being stored in XMM registers. And then we also get them returned as XMM registers, even though I'm not storing it anywhere. Where are we storing this? It's like this struct is getting stored. I guess to C always does he always store structures on the stack? Always? When you're not running with optimizations? So like if I do... whatever the optimization flag is. So I guess it's getting stored on the stack, even though the function doesn't... like, we're not using the return value from this at all. Okay, so this answers all of my questions about what I need to do here. That's what's wrong with my Discord server, I guess. Or discourse, not... Let's figure out what's wrong with my Discourse server. If I can scroll, which I can't. Oh well, I'll figure that out later. Yeah, let's get back to this. Okay, so we need to classify. We have 3 classifications, which is... ooh. I'm realizing that I might be able to restructure this casting code to actually be generic between multiple different types. I can actually, yeah. I can make this generic between multiple different types. So I'm just thinking this through. What are the different ways that we could do this? So the from or to int 8 bytes. This would just be from 8 bytes, and then we would need to pass in also a vector of either we'd pass in a second vector, which is the register types, or you'd put these 8 bytes in tuples. And then have those tuples store what registers we want to store them in, or instead of from int 8 bytes and to int 8 bytes, I think I'm going to rename these to act arguments. And then here, this is going to be our arg values. And then the other thing we need is archetypes. Or arg classes, I should say. So let's create a new enum. I'm gonna put it, I guess, here. Enum argument class, and this is going to be int float. Or actually, I'm gonna call it general. What does SSE stand for? Streaming SymD extensions. Okay. Let's general vector and memory are our argument classes. And then when we are dealing with packed arguments, we need to be able to get the 8-byte classes. Then into here, we want to pass self. Self. Then here we need to recursively walk value descriptions, and I also want a mutable vector here. Here. I need a result here? No. I do not need a result here. I think this should probably always succeed. Our code is always valid. This will always succeed. Probably, maybe. I'm gonna have a few expects in here. So we're gonna say self get 8-byte classes internal self description let classes equal vec with capacity. And then I think self size divided by 8. Size plus 1 divided by 8. No. Plus 7. That's how integer math works, right? This makes it floor upwards instead of floor down. If you add almost the value. Yeah, that's how int math works. Then this needs to be mut. Yes, I know it's unused. Ignore that for now. So now we need to match on the description recursively. So we're gonna resize this with this length. Yes, by default, we want these to be no class. I want to describe this. Inspired by the x86-64 SystemV ARG class concept. Actually going to link this doc there, minus the UTM source, chatgpt.com. Let's see. Often other register types will be bit passed to this vector. Used for float arguments. Often represent pass this or arguments that must be passed on the stack. Yeah, I do. Some ABI still send a pointer in wire pointer in its place. Others use implicit stack positions. Some both. Now we have the classes, and I did want to... Usually I don't document stuff too much, but in this case I really did want to document that. There was some some Vim navigation command that goes between definitions. I'm not quite sure what it was. That would be super useful right now, because I passed it. Here we go. Get 8-byte classes, resize with 8 bytes. Arg class, no class. So here, if this is a value, wait a second. This doesn't make sense because that would only work for if we already have a value, whereas when creating a signature, we don't have a value, we only have the type. So we should put this into here. So we're gonna say UI arg class. Don't need self, we just need an IR TY IR type. It would be really nice if we could do that with the already existing values, because then I could just check what are the actual values, flattened values of the structure enum. We can't do that, so this also needs IR of the module. Hmm. Get the classification be Our classification for a type. You know what this makes sense for? This makes sense to be put on implementation, not of the actual JIT backend, but underneath our class itself. There's some format you can do to actually specify Rust, doc, argument, explanation, syntax. That's what you're supposed to do. Let's see, so also syntax to like actually link to a type. I think that might be it. Yeah. Look at that. We can actually like jump to it. Could be initialized to our class. No class. Be a vector of length ceiling size of t. I'm like drawing a complete blank on how to describe this. Basically, As objects compare against current values, length should be long enough. Be size divided by 8 rounded up. Alright, that's close enough. That's good enough. Okay, now for the actual implementation. I've done this so many times. Okay, that is... Okay, and that is our boilerplate. Then we need to extend for enum as well. Cool. I'm gonna test something. Can I just say implement this? Does it work if I just say implement this? Oh no, it does not. No, it doesn't. Okay, so for every single one of these, actually not for the U64. Are you... These two, I don't even know if I want to support these anymore. Actually, I straight up don't. because on function calling conventions, they can't decide how to pass those things because they don't actually exist. Yeah. They like exist as a concept in some languages, but they don't exist as an actual like true runtime concept. And I think for the most part, I haven't implemented them anywhere else either. Then for the floats, we go here. For the pointer, pointer also goes here. Kind of funny now to me when people say like, "Oh, trust the compiler's smarter than you." When like the amount of optimization I've seen compilers do is simultaneously magical, but then there's other stuff where I'm like, "Oh, that compiler is so dumb." Mostly with my own compiler, where I'm going, my own compiler is so dumb. No, my compiler is not smarter than you. LVM is probably smarter than you. My compiler is not. At some point, I might need to... It might make sense to do some simple optimization passes or implement simple optimization passes for like crane lift IR, which would be interesting. I already know they have stuff like dead code elimination, all that stuff. But there are some things like where some stuff like merging some branches and whatnot would make the output of what I'm giving crane lift a lot better, and stuff that can't be optimized out, like loading enums from the stack and then storing enums to the stack, is like branching behavior that I can't pre-optimize for. Unfortunately. Enums are like a runtime level concept. And we don't have a stack. If I had a concept of a stack, enums wouldn't need to be a runtime level concept. Then also... Oh well. We're kind of locked into the way I'm going so far. And I do like the way I'm going. I like the no concept of a stack thing that we're doing right now. Unless it like somehow becomes insanely expensive for the compiler to deal with the amount of register overflow, which I can't imagine being a possibility. Anyways, this class merge function we have here is this algorithm. Why can I make this go away? There we go. So this class merge is A equal B if A equal B, return A. You know what? Screw it. Giant if else. One of the classes is no class. The resulting class else if A equals arg class memory, or B equals arg class memory memory. Else. There's probably a way to do this as a match statement, but I don't trust match statement order of execution. I know that they are kind of implemented behind the scenes as a giant if else statement. They can also be a switch statement. And also that the optimizer turns giant if else statements into switch statements sometimes. Anyways, there's a lot of like, the code you write isn't actually real. The compiler goes, all right, that's what you think you're doing. That's how you think you want to do what you're doing. But, you know, I know better. So if one of them, if A is equal to arg class general, or B is equal to arg class general, I don't care about this, because this we would just say arg class memory and be done with it. Otherwise, class SSE is used, which is arg class vector. So now in here, let's say let by index equal just be class is 0 most of the time, shouldn't it? I'm actually going to go with that. Just use rebound the slice. So we're going to say for all of these classes 0 could be equal to class merge classes 0 arg class general. In fact, we can make it simpler than this. This is kind of cursed. I did not allocate enough. Go with it. Does this work? Okay, there we go. So this is what actually does the classification. But here basically going to say yeah. If members iterate zip, and then layout by offsets. And then what we're gonna do is self I call this pipe art class. Pipe arg class. Or let a byte range equals offset divided by 8. UB start. UB end equals UB start plus +1 plus member Actually, the only thing we care about is the start index. So we're gonna do I guess subslicing is just a panic-prone situation. Ooh. Oh, you just do get with a range? Okay. I've sworn this is a trait, and now it's just a generic. Okay. let's just grab this bit of error checking here. Whew. All right, and that's all we need to do for struct, and that will properly classify all of it. And we basically do the exact same thing for enums. But we just flat out I'm gonna steal this line here. Just zoned out there for a second. Do we know the index? The index will always be int. And in the first int byte, so class equals our class general. And I should do a merge here. And here, instead of members, we want Sorry, it's during the day. Usually I'm not awake during the day. Let's see. And I think that handles everything. Oh, the thing I did want to mess around with was see how this handles unions. Wonder, can I nest structs just like put them here? Looks like yes. So if I have two substructures inside of a union. So this is how variants kind of work in Rust. If you define the layout of a variant in Rust, this basically could be the, if I did want to go like all in, This could be the discriminant of an enum, and then this could be data. This is basically an enum. So we should see this being passed as a single register, basically. Yep, we pulled this into a single register. This all is passed as a single register at the moment. My question is, if I put this as float, does it still get passed as a single register? Yes. Now, what if I do this? That's pretty cool. That's pretty cool. Okay. And it also works how I expected it to. Yeah, in the actual spec document, they don't specify how unions are supposed to work. They just say, oh yeah, split your aggregate type into 8-byte chunks. And I assume that means if you're writing a union, you overlap the 8-byte chunks of this structure and this structure so that, like, all the fields here and all the fields here are part of the, you know, the same classification algorithm, which is what I'm doing. But it does look like it can automatically... It does look like that's... My guess was correct, that that's what's happening going on. Because it is... Even though we have a union type here, it is passing the second half of the union in XMM0, regardless of, you know, what's going on here. So if I did an int here, that does change that second one to be an int pointer instead of float. And then that, once again, we get XMM0. Nice. I'm very happy with that. It's so clean to pass floating point stuff in the float register. That just feels so clean. It's gonna be a little bit of a pain, but it's fine. It's fine. Okay, now that we can get all of the type arg classes, I was zoning out thinking that we should probably be caching layouts, because at the moment we're generating them every single time we use them separately. So I feel like that's a good speed up that we could do at some point, is get both the caching or memoization system for layouts. They don't want to store the layout as part of the module, just because, like, it doesn't make sense. The layout can be deterministically determined from the type, always, because we have a specified layout. It should generally work on every single architecture. Now that we have our classes, we should go to from packed args, and we should have a slice of arg classes. Then here, in that native type, currently gonna match on a byte index. Well, not 8 byte. We're not matching on 8 byte index, but we're arg class equals arg classes. So I'm not using get here. I should be using get. Even though this is my code that can't be influenced by outside sources, so it would be fine to use an index here. to use, yeah. Then depending on the arg class for this argument, no class equals fail. Actually, no class means we don't do anything. But I don't think it should. We shouldn't do anything. We should treat it like it is supposed to be no class. Even though no class probably does mean an error. Cannot pass an arg, no class. I'm sorry, sir. This class has no riz. We can't pass it. Then if this is a general arg, this is where we put all of this. I don't want it set. I want byte set. Oh wait, I did check the 8-byte index. I just wanted to give it a good error message, I guess, so I did the whole big error. Whole big if statement there. feel like I lost my brain like 20 minutes ago, or at least ability to speak. The lack of ability to speak, or the inability to speak, does not make one unintelligent. Keep this one as is. This one does need to account for big casting stuff. For this one, though, see what types we have. We have float 12, 8, 16. So we can do 128-bit floating point. Dynamically scaled SystemV vector. The minimum of 2 lanes containing 16 bits each. So this is hard because let's see, C 16-bit or not int do standard guarantees a float double and a long double. Wait, standard bool H for float 16, if not implicitly why are floats in standard bool? So why aren't bools directly included? That's another thing. Like, okay. So include standard bool. That's interesting. For this, they didn't store a binary representation of it. Instead, copies the word in the source operand specified by the count operand to the destination operand. The source can be an MMX technology register or an XMM register. The destination operand can be the low word of a general purpose register or a 16-bit memory address. The count is an 8-bit immediate. When specifying a word location in an MMX technology register, I'm pretty sure that's our. No, wait, I said 42. EAX. Maybe it's because it's some multiple of 2. It's doing some weird workaround there. Then again, we do have this data section here. I don't know. I don't know where. I don't know where this data is getting stored. The important thing to know is that even with the half bit float here, this is still yeah, even with the half bit float, this is still whatchamacallit. I need my brain to work with me here. They're still all going to the same XMM register. Problem is, Crane Lift wants to strongly type the different vector register types. So what we need to do is match on the type. Native type. And for the majority of these, it's just Sony out there. This, all of those, as well as U64, I64, and pointer types as well. This read? This from pack target internal? Okay. So for this, we need to figure out if we have we need to bitcast R as F32 2 in this particular case. Because this is supposed to be an XMM register. So F32X2 by index this is probably initialized as whatever, it doesn't really matter, but it's let's do mem flags new. Now we have a typed vector of the type that we need. Brane lift. Read index of vector register. Please tell me I don't need to put it on the stack and then read back. Extract lane. So we're going to extract lane. Typed vector lane offset. That is the actual value. Then in this case, just want to say builder insert bitcast types. F64. I think will be valid. Like it should be valid to cast an XMM register to an F64. Maybe. Honestly, I am not sure. Yeah, so now we just copy this over to two packed args internal. Or as packed args internal. So now we're going to do as packed args. I kind of want to straight copy this, but I'll just rebuild it mostly from scratch. Some copying. Is there a way to set marks in Vim? Okay. How do I jump between them? Okay, that is really useful. I've needed that for a long time. Okay. What I want is this whole args class thing here. Instead of this, we're gonna do this. This is as packed args internal, so this is casting from past values into values that we can actually use. No. This is from values we can actually use into argument values. Okay. So we want to match on current type for general is just easy. You just straight up you bitcast it to an int. Then you're good to go. That's probably a display implementation for type. Okay, so we're gonna do typed vec. How do I set a lane? I don't want to stop giving me its IR. I want its intermediate representation. Construction builder lane. Oh, is it just insert lane? Yeah, there it is. Builder, insert lane, typed vec, lane offset. Right, we need a value. Which would be... value. X the vector, Y the lane. Okay. Or not the lane, the thing. Putting the thing I put into, and then the thing you put in, yeah. If type is float64, float64. It byte registers. If type is float64, value Alright, I do believe that okay, no. No architecture I know of does anything weird like a union where some union values go into floats and others ints, but they would have shared the same memory address. So we don't have to worry about we don't ever have to worry about a situation where this wouldn't work the way it does, I think. Oh, hey, Joe. How's it going? Long time no see. If you are the Joe I think you are. Which I think you are. I'm doing pretty good. I'm doing pretty good. Yeah, I have... my scripting language works with the C function calling ABI. So that has me pretty happy. Reading documents that look like this to get that working, which has been pretty fun. Yeah. Oh, yeah. And then pretty soon here, I'm gonna get to try out this, if I can pick up the box. Ah. So this is that new headset. The Samsung one. I'm gonna drive over and open that up with Thrill in a bit. Maybe today, maybe tomorrow, we'll see. So that's going to be really fun. I'm really looking forward to trying that out. Because, like, it looks like it's the Quest Pro, but good this time. Which, the Quest Pro is, like, very hit or miss. Could probably have used better resolution. Could probably have used a better CPU. A lot of people complained about how uncomfortable it is. This one might only be uncomfortable depending on like head shape. But other than that, it seems like it's fixed a lot of the other issues. What they said about Quest Pro. Yeah, this is true. But like, reviews so far haven't been terrible. Then again, nobody's used it for a long period of time. What I really want to do is just like do a month of streams like this with it on my face and see how I feel after that. Right now I'm preserving the box for the unboxing experience. But after, you know, Thrill's got his impressions of it, I might try to steal it. Alright, I think this all works. Oh, except for this. Should be fine. Am I sub-slicing 8 bytes? No. Fighting with that's new prediction library, trying to do more active ragdoll networking stuff. Nice. That sounds really fun. Okay, and now for all of these, this is Windows, so on Windows we can just pass it a static vector that is arg class general, and it should act the same as it did before. Fun is a strong word. I would probably find it fun. At least thinking about it. Maybe. There's a chance I would find it fun. Right, because match statements are actually a giant else-if statement, this needs to be at the end. Grandmother seems to be being kind of funny. To do like a bulk operation instead of individual scripts for muscles, but looking more and more likely. Oof. Kind of funky for Quaternions. Oh, is it like the, was it the W value is at the beginning instead of the end or something like that? Downright refusing to serialize, probably an error. Fun. No much help I'll be there. It is kind of funny how every single computer error is just trying to get data from one place to another. Like, technically, I'm writing serialization code right here, too. Technically, I'm writing code that writes serialization code, except it's like the serialization that happens every single time you call a function on the assembly code level. You know, similar to your problem. In the very abstract sense. Okay. I think I can now serialize structs to the format wanted by SystemV, System5, Linux x86. So now time to write all of the connective code. First, I need to finish writing the signature. Function signature. All computer. Everything is computer. Everything is computer. SystemV on x86 64. I do have to remember to put in the context pointer always. But let's see. So we need let moot remaining. Actually, what do they use here? Next NGRN, NSRN, NSAA. Nope, we are not using that naming convention. We're gonna say remaining. Remaining general registers and remaining vector registers. And in this case, we need to go here. We need to see parameter passing. There's all your different classifications. How to classify arguments, which we've already done. Then here, passing. So, if the class is integer, the next available register of the sequence RDI, RSI, RDX, RCX, R8, and R9 is used. That's 6 integer registers we get to work with. You know what I'm gonna do? I'm actually going to put we're gonna link the specs we used. I'm interested in this vector call thing. It specifies arguments for functions to be passed in registers when possible. Vector call uses more registers for arguments than fast call or the default x86 calling convention. This appears to be the same. Is this the same? Calling convention. But yeah, this is exactly the same. Okay, thank goodness. Standard call different. Used to call Win32 API functions. When in Rust, can you say extern standard call? Lou. So I was just going to grab this link. Before I get sucked down a rabbit hole, from XMM0 to XMM7. So that's 8, right? Then after we take the context pointer into account, that's and this will get optimized out. I just want to put the subtraction next to where it actually happens. The R11 is neither required to be preserved nor is it used to pass arguments. See a sixth argument. So here we need to account for the return value. So type is class memory, then the caller provides space for the return value and passes the address of the storage in RDI as if it were the first argument to the function. On return, Rx will contain the address that has been passed by the caller in RDI. Right, because they use... yeah. Actually am going to go and reference if we have a return type. This is a native type. We just do sig returns push native type. If it's struct or enum, So if first I need to figure out the size of this type. Hello. Welcome. Then after we have the size, if this is greater than 16 bytes, the size is 16 bytes, then sig returns push ABI param new self ISA pointer type. Because just to make sure, on return, Rx will contain the address passed by the caller in RDI. It is the general, just regular return register, so we don't need to worry about like specifically a register that would not be used in any other way, which is the case on Arch. So we would need a specific ABI param type for that. In this case, we do not, but we will need that for arguments. Not yet, though. And we also need to set has return pointer to true. And we also need to say Rx will contain the address that has been passed by the caller in RDI. Just to double check, RDI is the first argument. Okay. Pointer. Sig params, and we also need to see to do remaining general registers minus equal 1 because we do have less. General registers. We do have less general registers to work with. Then if this is not larger than 16 bytes, then we need to pass it as a set of arguments. Here's what I'll do. I'm gonna say our classes is I'm doing good. Not see. No. I'm just gonna statically allocate an array here. Then we're going to say arg class type arg classes for return type ir arg classes. I just realized that I say if arg classes contains arg class memory, we need to return this as a pointer. Otherwise, we just do for C in arg classes, and we can consume this. Then we do sig turns push No class, we do nothing. General. We're gonna say types I64. This is a vector arg though. Then we do 64. Which should be close enough. The 8-byte floating point type. An XMM register. Then for the actual signature, for native types, we just pass the native type, but I'm gonna do pretty much what I did for run type here. Let's do the pass. It's going to be pass as memory, and we're going to say ABI param special. And this is a struct argument of size. In this case, this does not subtract from remaining general pointers or general registers. Cannot find value return type. Right, this is an arg. No, param. This is arg type memory. We pass it as memory. And for class in arg classes, if it has no class, we don't pass it. It's general. Params push, params push, memory unreachable. And a surprisingly small amount of code. No, wait. I forgot. If size is greater than 16, let's see. We need... You need to get the number of general registers consumed and the number of vector registers consumed. And yeah. So we're gonna say for C in classes. I'm tempted to do this as a fold iterator. But I'm not going to. Alright, so if our classes contains... Oh, actually, we can do this first. To avoid iterating the vector again, we can do if general consumed is greater than remaining general, or vector consumed is greater than remaining vector, that accounts for the possibility of splitting a vector, or not a vector, that accounts for the possibility of splitting a structure across multiple, like if 8 bytes of its information can be passed on a register, but there's a second 8 bytes, we run out of space in our consumed, the number of registers we have. This spec wants us to just not pass it. Yeah. If there are no registers available for any 8 byte of an argument, the whole argument is passed on the stack. If registers have already been assigned from some 8 bytes of such an argument, the argument's assignments get reverted. So I'm just not assigning them at all. I'm also not the one doing the assigning. But the reason we had to redo the entire, like, checking every single type of the variables and counting them is because we're not actually the one allocating parameters. Crane lift is, but we kind of have to pretend that we are the one assigning. We do kind of have to pretend that we're the one assigning parameters. We done? I want to check to see, does it let us use the memory registers? So either it will hit one of my panics first. Nope, it looks like it let us declare them. Nice. Because before I was using other special parameter types and they didn't work there. Further do I want to go? Because I'm losing... I can tell I'm losing steam. Fair bit. We have 1 out of 4 functions done. And the utility function that we would use in those done. I need to eat some lunch. That's what I need to do. I'm gonna have to stun by the end of the day, but I need to have some lunch before I can do that. Yeah. So that's what I'm gonna do. I'm gonna go eat food, and then I'm gonna finish this. To those who stuck around on the stream, thank you. And I will see you next time.